Okay, class. Taking a look here, I want to go back to JetNet. This is in accordance with our first day of class. When you look at your JetNet site here and scroll down, I'm talking about here mainly the check-in assignments. I went over the other stuff yesterday, but the check-in assignments, remember I told you it would be under the particular week. So I added in another check-in assignment. I put in the assignment and also the section number. Now, if you were in class on Monday, I gave you all the check-in assignment for 1-1, so you did it on Monday. The check-in assignment, because we're going to get through 1-3 today, so you will also have 1-3 check-in assignment to do as well. Now, we are going to do some group quizzes that I'm going to demonstrate to you all today as well. I'm not sure if we'll be able to do 1 or 2, but we will be able to get through the group quizzes. Now, for those of you that may be watching this video, with you not being in the class, you would have to basically do the quizzes on your own, and also any of the classwork on your own. And the quizzes are due the Friday of the week that they are assigned, Friday by 8 p.m. So let us get started with this. Let me pull up. All right. So on Monday, we had left off on page, let's see what page it was, 7. We had finished up problem 13 and we were done with page 7. This was the first part of the 1-1 section. So now we're on page 8. Now, what I told you all is this here. If you do not have your course pack, if you do not have it, then what you should do in the notes that you are writing, you'll write down page 8, and then we'll write down the problems after it. If you have your course pack, you don't have to write down the page number. All you have to do is just start inputting the data. All right, now, so before we go ahead and finish off 1-1, I do need to know, were there any questions from Monday from section 1-1? Any questions from Monday on section 1-1 or anything pertaining to any of the information I went over? All right. I would say that that is a no. All right. So my next question would be as far as the check-in assignments. How were the check-in assignments that you all did? Were they easy? Were they difficult?
It seemed pretty, overall pretty explanatory, since we obviously worked through the problems. So to me, it seemed easy enough to understand.
Okay. Ms. Torres?
Are you talking about the ones online as well, or just the check-in ones?
Well, I was talking about the check-in assignment for right now.
Okay, well, yeah, the check-ins were completely fine. Just follow what the book says, and it seemed pretty easy.
Okay. Now, what about, I guess you were talking about the homework or the prep assignment. Did you have some issues with that you would like to discuss?
Oh, no. I found maybe a couple problems hard, but I went through with examples to help me, and it seemed perfectly fine after I got help from the examples or from the book.
Oh, okay. Okay. So you followed those steps that I told you online about the example and everything. Okay. Okay, good. I'm glad that was helpful. Okay. All right. So we actually have, let me see, to get through section 1-3, I just like to tell my classes how many pages we need to go through. in order to get a lesson completed. We're actually starting on page 8, and we are actually going to go to page 38 to complete sections 1 through 1-3. Now that sounds like a lot, but as we go through this, you're going to notice that it's not as bad as it seems. So on page 8, we start with number 1. It says numerous studies have shown that one of the best ways to do better in college classes is to study in pairs or groups. To help you get started, if you feel comfortable sharing contact information, exchange the information in the table below. The group you're in now will be your small group for the first unit of this course. When you get used to meeting in a class, you'll likely find that meeting outside of class to study and work on homework is a good idea as well. So include some study times that would be convenient for you to meet. Now, of course, this is a personal thing. If you feel comfortable giving your information to your classmates, that's fine. However, I would suggest, just for some personal precautions, like for instance, your cell phone number. You could get a Google Voice number. If you get a Google Voice number, it will give you a phone number that you could tie to your cell phone. So then when someone calls that Google Voice number, you could just basically answer it through your cell phone. And you could send text messages through that without giving out your actual cell phone number. And also your email. I mean, if you're going to give out your email address, I probably would stick with giving out the college's email address. Or if you don't feel comfortable giving out the college's email address, you can create an email address that's strictly for school. You could go, something that's strictly for like group work or something like that. You can go and create something on Gmail and, something very easy for you to remember. And that could be your email that you give out for group discussions. And then once the group is over or once college is over, you could just disregard that email and it would be no problem for you. But that's just a few options for you to think about. Okay, now, number 2, it says, let's look further into the idea of giving 110% effort. First, explain why a lot of people feel like saying that doesn't really make sense. Okay, so the reason why that doesn't really make sense, or do you all have an idea why that doesn't make sense to a lot of people?
Everybody kind of interprets everything they learn differently. So, I mean, some people might be visual or visual learners or what's it called, writing learners. I think there's more in depth of different learners, I believe.
Oh, okay. Anybody else? All right. And what you said, Ms. Torres, is true, that everyone learns differently. So it could look as though someone is giving a lot more effort than someone else. But if you look here, I'm just saying with the giving 110% effort. Now, as we all know, if you give 100%, that means everything. So 100% is everything. You cannot give more than everything. That's why that statement to a lot of people doesn't make sense. Because if you think about it, if you're giving more than what you did before, that typically means that what you gave before was not 100%. So the extra effort you're giving probably is your 100%. So that's why it doesn't make sense. Okay, number 3. It says convert 110% into decimal form. Then multiply the result by 200 to find what 110% of 200 is. Now, quick question. I have to ask this because I'm not sure if I went over this with your class. Did I go over decimals with you all and how to register for it?
I believe you did.
Oh, okay. Okay. All right. Well, let's pull up decimals. And I will. Let me pull this up. I'll bring it over here. Okay, we went to decimals.com. All right, now I want to go over briefly how to sign up for Desmos just in case I did not. So this would make absolutely sure that I did cover it with your class. Okay, now if you have not done this yet, after you go to desmos.com, you could click on create an account or create account. If you already created an account, you could click on sign in. So you click on create account. Now you have two options, a Google account option or email address option. If you have a Google account, all you have to do is check both of these here and then hit this bar here once it lights up. Let me show it to you. So now you can click on sign in with Google and it will have you sign in with Google. But let's say you don't have a Google account or you don't want to use your Google account. You can click on email address, type in the email address, and give your name, then make up a password, and then click on both of these, and then click on create account. All right. So that is how you would create your account. Now I already have an account, so I click on sign in, and I use Google. So I click on sign in with Google. Now, if I didn't, I would use my username and password below. Now, if you notice here, my name pops up. Now, I am going to show you all how, because we may have some assignments that you would need to submit to me using Desmos. I'm going to show you how to submit the assignment to me using Desmos. But first, let's take care of problem number 3. It says convert 110% into decimal form, then multiply the result by 200 to find what 110% of 200 is. So we know percent means divided by 100. So we could take 110 divided by 200. No, I'm sorry, by 100. It says divided by 100. And then we can hit this fraction bar here, and it will give us 11 over 10. Or we could leave it as a decimal. But it looks as though they want us to, let me see, convert 100 to decimal form. Okay, so they want us to convert this to decimal form, which we did. So we know that 110% is really 1.1. And then they want us to multiply this result by 200. So we'll multiply by 200. Our final answer here would be 220. Okay, next for number 4. It says, suppose that in a normal half-hour of practice, a tennis player expends 280 calories of energy. How many calories would she need to expend if she were to give 110% effort? Okay, so it would basically be the same as what we did for number 3. We got to convert the 110% to a decimal, which we already did. We know it's 1.1. Then we would have to multiply that by 280. So when we put this in our calculator, so we'll take 1.1 times 280. That would give us 308. and it's calories. 308 calories. Now that is to show that you extended 110%. Okay, now we're still on page 8, and it says here, now let's go shopping. If I had $1 for every time someone has asked me to calculate a discount price for them when a sign advertises a certain percent off, I'd be able to buy us both a very handsome gift indeed. In fact, shopping is one of the most common ways that people running loose in society are likely to encounter percents. My wife is an absolute wizard with Macy's coupons. As a high volume shopper there, she gets quite a few coupons in the mail. On one recent mall outing, she found a lovely red strapless number with a selling price of $79. She had 2 coupons to choose from. One offers $15 off any purchase of $50 or more. The other offers 20% off any item. Which was the better choice? Okay, so when we go here, wait a minute, let me make sure this page number. Oh, it's actually page 9. This is actually page 9. So we need to write page 9. Okay, problem number 5. Now it says find 20% of $79. So basically we want to change that 20% to a decimal. Now you have the option. You could take that percent sign off. You could take 20%. We could take the percent sign off, and we know the decimal is at the end, and move it 2 places to the left. And that would give us 0.2 or 0.20. Then we will multiply it by $79. So it'd be 0.20 times 79. Now, when we multiply this in our calculator, so we have 0.2 times 79. That'll give us $15.80, because this is money they're talking about. Okay, so the answer to number 5 is $15.80. Okay, number 6, it says, keeping in mind that you just found the amount the price would be discounted, which coupon would Kat have used? Now, if we look at these directions here, it says that one offer is $15 off any purchase of $50 or more, and then you had a 20% off. The 20% off is $15.80. So we know in shopping, the more you get off, the better it is. So it'd be better for you to use the 20%. 20% coupon is better because you get an extra 80 cents off. Okay, number 7. It says the sales tax in our county is 6.5%. Find the amount of tax on the dress purchase and the total cost including tax. Okay, so first, so this is number 7. Now, first thing that we need to do is take that $79 dress and subtract our discount off. So we would subtract the $15.80. And when we subtract this, that will leave us $63.20. Okay, now there's a 6.5% sales tax. So we would take that $63.20 and multiply it by the 6.5%. So when we multiply this out, this will give us $4.11 for the sales tax. Okay, now we want to find out the total cost as well. So we would take the $63.20 and add the $4.11. So it'd be $67.31. And this will be the total cost. Okay, are there any questions? And now we go to page 10. Problem number 8. It says, it's common for stores to advertise a certain percentage off, then say discount is reflected in the marked price, leaving you to trust that you're getting the percent off that they claim. Suppose that a refrigerator is listed as 30% off with the sale price of $749. What would that make the original selling price? Okay, so let's look at this. Now, I just want to write off to the side some of the things that we were looking at. Now, you don't necessarily have to write this, but I write this myself. We have 30% off. And then what we want to do is find, and we have the sale price. The sale price is $749. So we have the 30% off and the sale price is $749. So now we need to find the original selling price. So first of all, we know that we do not know what the original selling price is. So we would do that as an X value. X, we know in mathematics, is unknown. And then we would say X times some value is supposed to give us $749. Now, the reason why I left that blank is because of this here. We're told that we get 30% off. Now, a lot of people would feel compelled to use the 30% that we see in the problem. But the 30% off is not going to help us with this. It'll actually give us a number too large for this problem. What we have to look at is what we're actually paying, because it's 30% off of what we're actually paying. So what we're actually paying, if we were to pay the full price, would be 100%. So we would subtract the 30% off, and that would leave us 70%. So it'll be the regular price times the 70% we would pay would give us $749. Because now they did not ask us what the discount is. They're asking us to find out what the original price is. So it's a different process like you see here. So now, when we multiply this, it'll give us 0.70x is equal to $749. We divide each side by 0.70, and x is equal to $1,070 is the original price. Does everyone follow that? Okay. All right. Now we move on to number 9. It says a large latte at Shakey's Caffeine Shack usually sells for the low price of just $3.50. But today Shakey has gone goofy and is offering it for just $3. Wow. Why not just give them away? Is this a better offer than the 20% off the coffee shop across the street is offering? Okay, so we go here to number 9. So the first thing we need to figure out is which one gives us the better deal. So in doing that, we could do this here. Shakey's, they went from $3.50 to $3. So it was a savings of 50 cents. Okay. So now, the other company says they're going to give 20% off. So we're going to assume that their shakes were $3.50, and they're going to give 20% off. So we could find out the discount price by multiplying it by 0.20. Now, when you put this in your calculator, it will give you 0.70. So the better deal is the 20%. So 20% off is the better deal. And then you could put by 20 cents. It's a better deal by 20 cents. All right, are there any questions? No questions. Okay. All right. So now, I told you all in the last class period, every time we go through some of these pages in the course pack, when you see these 10 boxes, you need to pay attention to them, because typically they have some type of benefit to the lesson. So it says computing percent increase and decrease. When some quantities get larger, we calculate the percent increase using the formula. Percent increase is the amount of increase divided by the original amount. So it's the new amount minus the original amount divided by the original amount. Now, if the quantity gets smaller, we calculate the percent decrease using a formula. Percent decrease is the amount of the decrease over the original amount. It's the new amount minus original amount divided by the original amount. Now, I want you all to pay attention here. Both of these formulas are exactly the same. So all you have to do is just remember the formula for one of them, and you had a formula for both. So the formula for percent increase and percent decrease is exactly the same. Now, on page 11, we're going to go over a problem. Problem number 10. It says on July 24th, 2009, the federal minimum wage was raised from $6.55 to $7.25. Find the percent increase. So now, this is how we would do this. Remember, percent increase is equal to, now I'm going to change it slightly. You know, it's the new value minus the original value divided by the original value. We could change it to new minus old divided by old. So that's basically the original value is always the old value, and then the new value is always the new value. So our new value here is the $7.25. The old value is the $6.55. And then it's divided by the old value, which is $6.55. So now we will end up with 0.70 over 6.55. Now, when you put this in your calculator, as a matter of fact, let me put this in a calculator. We will have 0.70 divided by 6.55. Now, if you notice, we have a very long decimal here. So what I would do, I would round to 3 decimal places. So that would give us 0.107. And then, because they asked us to find a percent increase, our final answer must be written as a percent. So this would be 10.7%. Now, you could have moved the decimal 2 places to the right, or you could have took your answer of that 0.107 and then multiplied it by 100. And then whatever answer you get here, you'll put a percent sign behind it. All right. Now, what we're going to do Problem number 11, we really don't have to do here. But if we look here, problem number 12 and 13, I may have you all try on your own. Well, actually, let me go over number 12, because number 12 has a little something different with it. All right. It says here, we would never, ever accuse any advertisers of being deceptive. Wink, wink. But let's just say that it's not uncommon for percents to be used incorrectly in marketing materials. Let's look at one such case to close our review of percents. A department store advertised that certain merchandise was reduced 25%. Also, an additional 10% discount card will be given to the first 200 people who entered the store on a specific day. The advertisement then stated that this amounted to a 35% reduction in the price of an item. Explain why the store marketing manager is either a liar or bad at math. Show calculations to back up your explanation. Okay, now, they said we could show calculations. So let's just do it like this. Let's say an item costs $100. I like to use a nice round number. And then the item is supposed to be reduced by 25%. So if reduced by 25%, that means you only paid 75% for the item. So now the new price is $75. Okay, now, they told you to take an additional 10% off. So if you take an additional 10% off, that means that with that $75 that you had after taking 25% off, you're only going to pay 90% of that $75. So if we take our calculator, and we could take 0.75. Oh, I'm sorry, not 0.75. 75 times 0.9. That would give us $67.50. So this is how much you would pay by doing 25% off and then another additional 10% off. Now, this is the first segment. Now we're going to the 35%. So we take $100 times. If you take 35% off, that means you're only paying 65%. Because it's 35% off 100%. 100 times 0.65 is $65. So after you do the 25% and an additional 10% off, you pay $67.50. But if you took the whole 35% off, you only pay $65. So there is a difference. Now, it says explain why the store manager is either a liar or bad at math. So basically, there is an additional $2.50 that is owed by the first method of an additional 10% off. And I'll just say this myself. I believe the store is being deceptive. And I will tell you why. Before I came to Jackson College, I used to sell Coach purses. and I used to buy the Coach purses from Birch Run. So I went into the store, and I would go to the wall where they had an additional 50% off the outlet Coach store. So when I walked in the store, I was handed a coupon that said that I could take an additional 30% off any item in the store. So, I got excited. I was like, oh, wow, 50% off and 30% off. I'm getting 80% off. And so I'm calculating that. I'm like, wow, I'm only paying 20% for a Coach purse. So then when I get to the register, it was significantly higher than what I anticipated. And then I sat down and thought about it and figured out that they were able to make more money by telling you get an additional 30% off, because just like here, when you get that additional amount off, it's not based on the original number. Remember when we did the 10% here, the 10% was off of the new value, which is lower. But if it would have been an additional 10% off here, that would have subtracted another $10 instead of what's that? $8? No, $7.50. So yeah, so I think they were being deceptive. Yeah. But okay, problem 13. It says in promotional materials, a company that increased their workforce from 1,000 to 1,500 workers claimed that they hired 50% more workers. A rival of theirs bragged about decreasing emissions from 1,500 to 1,000 cubic feet per day, claiming a 33% reduction. Which company is lying? Explain. Okay, let's do this. Let's do percent increase. And then percent decrease. And see if these numbers match up. The first claim was that the company increased by 50%. Now we know percent increase is new minus old divided by old. So the new value here would be 1,500. The old value would be 1,000 divided by 1,000. So this would be 500 over 1,000, which we know is 50%. So we know the first company was telling the truth. They hired 50% more workers. Now we go to the percent decrease. It's still new minus old divided by old. The new value was 1,000 because remember, they're reducing. The original value was 1,500 divided by the 1,500. So this would be a negative 500 over 1,500. And then if you simplify, if you round this value, matter of fact, let me put it in the calculator so I can show it to you. All right, so if I took a negative 500 divided by 1,500, you notice it gives us a negative 0 point and repeating threes. So what I'm going to do is assume that we're supposed to round to the nearest whole percent. So this would be a negative 33%. So this would be a negative 33%. So now, one thing before we answer the question here, let me put the negative up here. Okay, this is a negative 33%. This is 50%. With percent increase and percent decrease. With percent decrease, even though it has the formula, percent decrease is always, when you're doing your answer, is negative. Percent increase is positive. Now, when you're writing a statement, you more than likely would not write the negative sign for percent decrease, but I'm going to show you how you would craft a statement. So you could say this, if we are rounding to the nearest percent, both companies are telling the truth. first company did increase their employees by 50%. And the second company reduced their employees by 33%. Now, if you notice here, by me saying reduced, or I could say decrease, I wouldn't have to put the negative sign there. So I will write that positive. So that's what I mean. Even though the answer is negative for the decrease, it's still looked at as a positive when you're writing it out as a statement. Okay, so now we just finished section 1.1. So we are going to move on to section 1.2. Oh, okay. I'm going to have to sign back in to connect math to get to section 1.2. Yeah, log me out. Okay, class, now we're starting section 1.2, which starts on page 17. And it says, where does the time go? We have our learning objectives. We're supposed to complete and analyze the weekly time chart, review a variety of calculations that involve percentages, create and interpret pie charts by hand, use a spreadsheet to create a pie chart. Okay, now, this lesson here, I think is going to be very, very good for you. But what I want to do is look down here. It says, where does the time go? I'm not asking in a philosophical way, as in holy smokes, it's almost Halloween. Where does the time go? I'm thinking more literally. Where exactly does your time go? Have you ever kept track of what exactly you accomplished with the 24 hours you're given every day? If you have very limited funds, you have to be very careful about how you spend what you have. But we all have limited time. And not many people think about whether or not they're using that time wisely. Number one, what does the quote at the beginning of this lesson mean to you? And some of you all tell me, what does this mean to you? What does the statement, where does the time go, mean to you?
Is it like the red, the word, the time, where does the time go, or is it the quote at the top too?
It's the where does the time go?
Oh, okay.
Yeah, what does that statement mean to you? No one? Okay. Basically, it's just that quote is basically asking a question of what are you using your time for? Because a lot of times when people ask, where did the time go? Most of the time they cannot tell what they actually spent their time doing or accomplishing. Because if you know what you were doing and what you were accomplishing, you wouldn't be asking where did the time go? So, and number two, write down the 3 activities that you think you spend the most time on during an average week. Don't think about it too much. Just come up with 3 off the top of your head. All right. Can you all give me 3 activities that you all do during the week?
In my case, I would say dishes, cooking, and laundry.
Okay. So page 17. So dishes, cooking, and laundry. Sounds like very exciting task.
Yeah. Well, 3 kids will keep me busy.
Oh yes, oh yes. And I have 2 myself. Yeah, so what about
Um,
you?
Mine are by studying, taking notes, learning activities for my kid, and reading books. I rarely get time to watch TV.
Wow. And you said activities for your child?
Yes, my son he's autistic, so I have to keep him on a schedule of learning, not get him behind on
Oh,
his
okay.
communication. So
Okay. I understand that. I understand that. Well, Ms. Nito?
I go on the trails quite often, and I do a lot of cleaning and homework.
You say you do a lot of what besides the trails?
Homework and cleaning.
Homework and cleaning?
Yeah.
Oh, okay. All right. Well, I'll just tell you all what I do. I just I do a lot of sitting at home being lazy and let my wife do everything. No, I'm just kidding. No, I do a lot of reading, working with my children with their homework, and as much as I can, I try and sleep. Those are my main activities. So, no, yeah, we have various activities that we all do. It takes up a lot of our time. But let's take a look down here. We want to talk about this chart as you all see it. Let me expand it out for a brief moment. You notice this chart goes all the way to Saturday. Now, this chart here, if we continue to go down, will be used for number 3 here at the bottom. And this is page 18. It says, count the number of spaces containing each letter in the time chart, CHSWO. Use the results to fill in the following chart, writing the total number of hours devoted to each activity during 1 week. Okay, now if you notice here, the CHSWO are the first initial of these different activities. So with number 3 for class, I'm going to give you all the amounts because we really don't have enough class time to count all of this. So with class, that would be 15 hours. Then homework would be 32 hours. Sleep would be 54 hours. Work is 15 hours. And other is 52 hours. Okay, now we're going to take this information and we're going to do problem number 4, which starts on page 19. It says, without adding the hours in the table, how can you decide what the total number of hours should be? How would you decide that for the total number of hours for a week without adding up the table?
Like how many hours are in a week?
Yes.
like a mathematical way or like just a guess?
Either one is fine. Okay, well, I see no one wants to take that leap right now. Okay, if we look at this in the sense of it's 24 hours in one day.
So 168 hours in a week.
Right. Times 7 days in a week is 168 hours. That's how many hours you have in a week. So when you add up these values here, it should equal 168, and it does. Now we look here at number 5. Number 5 asks us, it says most college advisors will tell you that a good rule of thumb is to allow 2 hours of study time outside of class for each hour spent in class. Is a student that filled out the table in question 3 following that advice? All right. So if we look here at question 3, as far as study time, that would be basically your homework, which is 32 hours. Now it says, good rule of thumb outside of class for each hour is a student that filled out the table in question 3 following the advice. Okay, now, if you look here, the class time is 15 hours. We're told that it's good to spend 2 hours per hour in class. So we'll multiply that by 2. So that student is supposed to do 30 hours, according to the advisor. But if you look here at the table, they're doing 32 hours. So basically, they're doing very well. So we will put they are doing 2 hours above what is recommended. So they are doing well. Okay, now number 6. It says use your results from questions 3 and 4 to fill in the next chart with the percentage of hours in a week devoted to each activity. All right, so number 6, we will still do the activities. But this time, instead of using the hours, we'll use percent or percentage. Okay, so we add class, homework, sleep, work, and other. All right, now, how do you all propose that we get the percentage here?
Is it, I think you said, was it divide by 100?
Okay. Yes, when we talk about percent, like changing the percent to a decimal, we do divide by 100.
Oh, okay.
But I'm asking, how do we get a percent here? Okay, well, let me ask you this. Let's just say we did not need to sleep. Let's just take that out the equation. And let's say that you managed to stay in class every single hour out of the week. So you spent 168 hours in class. What percent would that be for the week? Hello?
Can you repeat the question that the question you just asked right now again? Sorry.
Okay, it's no problem. I said that if you spent 168 hours in a class, I'm talking about straight all week, you didn't need to sleep. What percent of your week's hours would you be in that class?
It'd be 168%, right? Because you said we don't have to sleep,
100%.
so
Right, that'll be how many hours you have, but what percent of the hours would that be?
Wouldn't it be 100%?
oh,
Yes, it would be 100% because it's 168 hours in a week and you spent 168 hours in class. So that would be 100%. Does everyone follow that part?
yes, now I do.
Okay, now, so basically, what we would have to do to get the percentages here is take whatever amount that we have for class back in question number 3, which is 15 hours. We would take that value and divide it by the 168. Because remember, this is 15 hours out of 168. Then this would be 32 hours out of 168. Do you all follow that?
Yeah, I do. Yeah.
Okay. So we will put that in our calculator. Let me move it over here. I think it'll be better over here. Okay. So, in putting this in our calculator, we have 15 divided by 168. Then we're going to round this to the nearest whole percent. So that'll be 9%. So it'll be, is that 15 over 168? So it'll be 9%. Because we know with a percent, we have to take this value, round it 2 decimal places, and change it to a percent. Then next, the homework is 32 divided by 168. Rounded to 2 decimal places, that would give us 19%. Then the next value, we would take the, what's that, 54 divided by 168. On that to 2 decimal places, it'll be 32%. And then work is what? 15 hours is the same as class. So work would be 9%. And then finally, other is 52. So we'll take 52 divided by 168. Rounded to the nearest percent, that'll be 31%. Okay. Now that takes care of problem number 6. Now we come here to problem 7. It says studies have shown that college students get about 6.5 hours of sleep per night on average, but that academic achievement improves when students average 8 hours of sleep. What percentage of the hours in a week would be devoted to sleep if you get 6.5 hours of sleep per night? What if you get 8 hours? How is your friend from question 3 doing when it comes to sleep? Okay, so this is what we would need to do. Problem number 7. We would take, first of all, we know in a week it's 168 hours. So now it's 7 days in a week. So we would take 6.5 times 7. Now 6.5 times 7 is 45.5 over 168. So now we would divide that. So we have 45.5 divided by 168. So when we round that, that would give us 27%. Now, we're also asked about what if it's 8 hours? So we know we're still going to do it by divide by 168. And we know 8 times 7 would give us 56 over 168. So we need to put that in our calculator. And that would give us, if we round to 2 decimal places, that would give us approximately 33%. Now, the question is asked, how is our friend from question 3 doing when it comes to sleep? Now, if we look here at sleep, they're at 32%. They're slightly off. Or we could go back up here to the third chart here and see that they do 54 hours of sleep per week, whereas the 8-hour person do 56 hours per week. So we could write down they are almost at the sleep level they are supposed to be. So we could put that they are almost at the sleep level that they're supposed to be. Now, do any of you get 8 hours of sleep?
Yes.
Oh, you get 8 hours?
Oh, yeah.
That's great.
That's a no for me.
Say what?
That my priorities got them straight. Sleep's number one.
Oh, sleep's number one. But is there anybody that doesn't get 8 hours of sleep?
I definitely do not get 8 hours of sleep every night.
Oh. Is it you have children, right?
Yes, but I like, even though they go to bed and get their amount of sleep, I like to stay up and just relax, so that kind of tends to interfere with my 8 hours.
Oh, okay. You like to relax. Yeah, there's nothing wrong with that. And I can understand that. Sometimes you do need that little quiet time. That's what my wife and I call it, quiet time. Yeah. Oh, yes, it helps. Okay, let's go here to page 20. It says number. You said what, Ms. Torres?
Oh, I'm sorry. We're on page 20. I got a phone call from my boss, and I had to leave for a moment. So.
Oh, okay.
Did you give break or something?
No, it was no break.
Okay, so you guys were just talking. Okay.
Okay.
I'm not like lost.
Okay. All right. So now on page 20, it says a circle can be divided into 360 equal units of measure, which we call degrees. In other words, an entire circle is made up of 360 degrees. The degree symbol represents degrees. Multiply the decimal form of each percentage in question 6 by 360 and put the result into the next chart, round to the nearest whole degree. Okay, so let's do a quick little chart here. Now, finding the degrees is not that bad. So let's go through that, because I know especially in math, a lot of times students have been told things are not that bad and then they turn out to be bad. So hopefully I could prove to you that it is not that bad. All right, now I'm going to have to go back here, try and put these side by side. So I want to go back to these percentages. So they're telling us to find out the degrees. This is what we would need to do. See if I get a little bit more space here. Okay, for class, we know this class is at 9%. So we will take 360 degrees times 9%. And when we multiply that, we're round to the nearest degree. So that'd be 32 degrees. Next, we will take 360 degrees times the 19%. And that would give us 68 degrees. Take 360 degrees times 32%. And we have to change that percent to a decimal, and that would give us 115 degrees. Then work, we'll take 360 degrees. We know that it's at 9%, like it was for the class. So we know that that's 32 degrees. And then last but not least, we had 360 degrees times, it'll be 31%, which is 0.31, which is 112 degrees. So that is how you figure out degrees. You have to find a percent and then multiply by the degree, and then that would be your degree value. All right, now we move on here. But before we do, are there any questions? We're actually almost done with section 1, 2. Are there any questions? Okay.
So I do have a question.
Yes.
So you would use that method, the 360 degrees, to find for any number?
For any degree.
Yeah, for any degree.
Right. If they ask you for the degrees, well, let me make sure that yes, if they ask you for degrees, they're talking about, for this course, they're talking about a circle, which is 360 degrees. So it's always 360 times whatever percent that you have.
Okay.
Right. Okay. All right. Now, we need to go to, let's see, what page is this? Page 23. Need to go to page 23. All right, now, we're not going to create a pie chart, but if you do want to create a pie chart, you can read these directions and it would walk you through how to create a pie chart. But we are going to get to the interpretation of a pie chart, starting on page 23. All right, so we have page 23, problem number 2. It says, a national survey on college students and work was conducted during the 2003-2004 academic year and reported on the website, basically acenet.edu. The results are summarized in a pie chart. What range of hours worked was most common? Okay, we look here. What range of hours was most common? Anybody?
I'm sorry, what was the question? Are you talking about number 3?
Yeah, number 2. What range of hours work was most common?
1 to 20.
Yep, 1 through 20. That had the largest percent, 1 through 20 hours. Okay, number 3. It says, what percentage of students work between 21 and 34 hours per week? And that's given to us. You said what?
21%.
Yep, 21%. Number 4. Now, this is a quick blast from the past. It says, how many degrees make up the angle for the sector representing students who work from 1 to 20 hours per week? So how will we get that?
360 times 0.35.
That is correct. 360 times 0.35. And that would give us 126 degrees. Okay, now, page 24 is basically the last of this section. Problems 5, 6, and 7. And then we're done with 1, 2. Okay, it says in questions 5 and 6, be careful. The questions may refer to more than one section of the pie chart. Okay, number 5. On a campus with 7,500 students, on average, how many would you expect to work at least 1 hour per week? So we would need to look back here at the chart, and they tell us it's 7,500 students, and how many would we expect to work at least 1 hour a week? So what values show at least 1 hour per week? What values in the pie chart?
The 1 to 20 hours.
Okay, that is partially correct. So 0.35. What does at least mean? Okay, just to give it out here, at least means that value or higher. So when they say at least 1 hour, they're saying 1 hour or higher. So it'll be the 1 through 20, the 21 through 34, and also the 35 or more hours. You'll add all of these up, you'll get their percents and add them up. This will be 75% or 0.75. So we would take this value. We're told that we have 7,500 students, and we'll multiply it by 0.75. So it'll be 5,625 students who work at least 1 hour a week. So that would be your answer for number 5. Now, number 6, it says on the campus in question 5. Oh, let me scroll down here. On the campus in question 5, how many students would you expect to work less than 21 hours? So when you say less than 21 hours, its values lower than that. So less than 21 hours would be these two values here, the 1 through 20 and the none, because that is less than 21 hours. So that would be 25% and 35%, which is 60%, but I'm writing them as decimals. So we would take our 0.60 and multiply by the 7,500, and that would give us 4,500. Okay, number 7 and the last problem. It says, how do you think these results will compare with a similar survey conducted for this school year? Why do you feel that way? Explain. Basically, I think these results would not reflect this school year because of the coronavirus. Yeah, it wouldn't reflect it because of the coronavirus, because we are on lockdown or stay-at-home order. So most people would not be able to go out and work. Or some people are working a lot more hours than they normally would because they are considered essential workers. All right. So now we move on to 1-3. Now, let me pull this up. Hopefully I could pull up the ebook again. All right, 1-3 actually starts on page 31. All right, so now on page 31, it says here, it's all about style, learning objectives. To identify and understand your learning style, to create and interpret bar graphs using spreadsheet and by hand, Decide whether a bar graph or pie chart is more appropriate for a given situation. Okay, so we're going to scroll down here, page 32. It says, a bar graph is a visual way to compare the sizes of different values. Pie charts are great for comparing parts to a whole. Bar graphs are effective for comparing parts to other parts. In a bar graph, the length of each bar gives an indication of how the size of a quantity compares to other related quantities. The bar graph below shows the percentage of global internet users that visit the top 5 most visited sites in the world. Just by looking at the heights of the bars, we can see how the percentages for these sites compare. By looking more closely at the scale on the vertical axis, we can get a good estimate of the actual percentage for each of the top 5 sites. Number 3, which site has the highest daily reach? What percentage of internet users go to that site on an average day? Okay, if you look here, according to this chart here, and this is page 32, if you look at number 3, the highest bar here is Google. So if we look here at Google, we have Google, and it's not quite 50%, it's just under it. So we could either go 48% or 49%. Either one of those answers would have been acceptable. Now, I wouldn't expect you to write 48 or 49%. I'm just telling you the 2 answers that I would have accepted here. So you can either write 48% or you could write 49%. Okay, number 4, which is higher? Google's daily reach or the combined daily reach for YouTube and Yahoo? Okay, so let's look at YouTube and Yahoo. YouTube is about, I would say about 33%. And then Yahoo is at about 23%. So together, if we add those 2 together, that would be 56%. Now, we already said that Google is 48 or 49%. So basically, YouTube and Yahoo has a higher percentage. Okay, number 5. I did some poking around on the internet and found that in an average day, about 690 million people visit Facebook based on Facebook's daily reach. How many people access the internet each day? Okay, now let's take a look here at Facebook. Facebook looks to be about 42%. Okay. So basically, we would take 42%, which is Facebook, times the total internet. What they ask you, how many people access the internet each day. So it'd be 42% of how many access the internet each day would give us this 690 million. Because remember, Facebook is 42% of the total daily reach of the internet, or total people signing into the internet. So we would divide each side by 0.42. And then this would be X, it'd be approximately, it'd be about 1,642,857,143. That'll be about how many people log into the internet each day. Okay, number 6. It says, I also found out that an estimated 3.3 billion people are internet users. What do you think accounts for the big discrepancy between this number and your answer to question 5? There's a variety of answers you could give, but you can just say one is an estimate and the other is actual. Because remember, when we did the Facebook analogy, we were doing an estimate. And they told you that it was an estimate. Okay. Now we have a few more problems to do, and then we will go on to the rest of the activities for today. Let me scroll down here. Okay, we need to go to page 35. Now on page 35, it says here, the Harris Interactive Polling Agency surveyed 2,094 consumers in October of 2012, asking which former president they would most enjoy having a burger with. The top 4 vote getters are summarized in a bar graph. Which former president had the highest percentage, and what was the percentage? Okay, so if you look here, it looks as though Bill Clinton had it. And if you notice here, it's between 20 and 25, so it'd be more like 22%. So this is page 35, number 1. It'd be Clinton and 22%. Okay, number 2. How many of the respondents would most enjoy having a burger with the most popular choice? So they tell us that it's 2,094 consumers. And we'll multiply by the percent, which is 22%, which will give us about 461. Now, number 3, it says which 2 presidents tied in the poll? It'll be Reagan. If you look here, ones that look as though they tied is Reagan and Kennedy. So it's Reagan and Kennedy. How many people chose a president not in the top 4? Now, this is where it gets a little tricky, because this graph here only deals with the top 4. It doesn't deal with all of the presidents. So what we would need to do is get the percentage of everyone that's in the top 4. So we already had Clinton at 22%. Reagan and Kennedy, if you look, they're about 14%. So we could put both of them down at 14%, so they are the same. And then finally, Lincoln is at 15%. Now, when you add all of them together, it'll give you 65%. So now, 65% of the people polled pick one of the top 4. So now that means that 100%, if you take 100% minus the 65%, that means 35% chose someone else. So we would take 2,094, which is the total population that was polled, and multiply it by 0.35, and that would give us 733 people that chose someone outside of the top 4 choices. Okay, now we come here to number 5. It says, describe how Ford performed in 2008 and in 2010 in terms of profit or loss. Now, if you look at this bar graph here, you notice here at 0, that's the break-even point, which means they didn't gain any money, they didn't lose any money. But they asked us, how did they do in 2008? It went a negative 15. So that means they lost 15 billion in 2008. Now they ask us for 2010. They had a gain, or we could say profit, of $7 billion in 2010. All right, now they ask here for number 6. It says, what were the best and worst years for Ford from 2007 to 2011? So basically, the worst year, 2008, was the worst year. And then 2011 was the best year. So we just go lowest and highest. Okay. They said explain why you decided. So 2008, worst year, lost the most. And then here for 2011 being the best year, they gained the most. Okay, number 7. It says, what was the largest single year increase in profit? Okay, if you look here, it would almost look like the most single year would be from 7 to 20. That's an increase of 13 billion. But the biggest increase was from 2008 to 2009. Because remember, they had to gain 15 billion in order to get to zero. And then another 3 billion in order to be 3 billion above breaking even. So they gained $18 billion between 2008 and 2009. So 2008 to 2009.
Why would it not be 2011? Wouldn't they gain 35 billion?
You said 2011?
Yeah.
Oh, no, they said in a single year. They said largest single year. Right.
Yeah.
Right. Okay. And then now number 8. It says a mathematical way of expressing profit is to use a blank number. And then it'll be a positive number. And then a blank number is used to express loss. It'll be negative. And for problem 6, I should have wrote this down. This was page 36, starting with problem number 6. Okay. Then we have one more. If you go to page 38. Okay, on page 38, problem number 15, it says, which company had the greatest variance in trade volume over that period? It says, write a sentence. Okay, the company that had the greatest trade variance was Apple. And if you look here, Apple, it was going up and went down. It was very inconsistent as far as how much it was jumping around. All the rest of them were very close to each other. So what you could say is Apple had the greatest gains. And losses. In problem 16, it says, which company had the most consistent trade volume? That would be Intel. If you look at Intel from these numbers here, you notice that their volume was really not changed that much. Really wasn't changed that much. So they had the most consistent, which would be Intel. So you could put did not change much. And then finally, number 17, it says, which company had the lowest number of overall shares traded during that period? And that would have to be Microsoft. because basically Microsoft, it had the lowest trades almost each year or each month. Okay, now that is basically it for 1-1 through 1-3. Now I did